Okay, we're back, and we're going to be talking about pseudoscience in Chapter 4. You're going to notice that this is a recurring theme throughout the quarter that we're going to talk about pseudoscience. And so it's really important that you understand what it is and how it differs from junk science and how it differs from real science. So, what is pseudoscience? Well, you might recognize the component parts of the term, right? You know what the word science is. And you've probably heard pseudo before and probably have an inkling about what it means. Pseudo means not real or fake, or it might mean imaginary, something like that. So what does that mean? What it means is that they're going to make claims, particularly claims that appear to be scientific, but they are based on uncontrolled evidence. So they're going to make claims about the efficiency or the effectiveness of a treatment or a program. Or they're going to make claims about the success rate of some kind of, event. They're going to make claims, but they don't really have scientific evidence to back it up, but they're going to kind of try and imply that they do. Whatever evidence they might have is never presented for public scrutiny. They don't publish their results. They don't go to conventions that are, scientific conventions where people could ask methodological questions and things like that. They don't want to hear any feedback about their materials. They just want to tell you about how effective and awesome and new and revolutionary their treatment or program or whatever it is. So sometimes other researchers will say, okay, this person is making this claim, so I'm going to attempt to follow what minimal information they gave us about how they found the effectiveness of this. And we're going to try and see if we can get the same basic outcome. So let's imagine that a pseudoscientist has made the claim that they have a new alternative treatment for cancer that, works on people who have stage 4 cancer, and it'll cause the disease to completely remit within 2 weeks of treatment, which is actually something that I found on an actual website. So a scientist might say, okay, well, let's test this. Let's see if we can actually replicate what this pseudoscientist is claiming, right? So when they do all the proper scientific controls, they discover that they can't get the same outcome. Now, in previous lectures, I've talked about how the failure to replicate does not necessarily mean that the first researcher was wrong. I want to put a big asterisk next to that and say I was talking about scientific researchers. So when a person is doing all the scientific protocols and they report their methodology and they put their information out for public scrutiny and all that stuff, when everything's been done in the scientific fashion and a different researcher doesn't get the exact same outcome, that doesn't necessarily mean that the first researcher was wrong or was misleading us or something like that. It could mean a lot of different things, that the second researcher didn't follow the design exactly the right way. It could be that. It could be that the outcome is really dependent on your sample, right? Like it works for some people better than it works for other people. That doesn't mean the first researcher was wrong. It just means that maybe it's not as generalizable as we thought. So I just really want to qualify that last little bullet point because, I had previously said, well, just because it doesn't replicate doesn't mean it's wrong. But I was talking about actual science in that case. So when we have a pseudoscientist claiming, my new treatment does these awesome things, and no one else can get those awesome things to happen when they use scientific protocols to test that claim, we have to say, I'm not sure you got that finding either, Mr. Pseudoscientist. Pseudoscientists are really good at denigrating the scientific community. They'll oftentimes say, well, you think that because you're buying what the American Medical Association is selling. I mean, if that's the way that you want to go, I guess that's how you can go, right? They'll sort of put it down, make it seem like you're just ignorant or you drank the Kool-Aid or something like that if you're asking for scientific evidence. They'll scoff at the need for controlled evidence. They'll say things like, why would I need to do a controlled study where some people are going to get the placebo when we already have all this evidence from all of my satisfied users that it works? Like, why would I deprive people of this treatment just to test this, controlled placebo-based scientific way when I already know it works? Like, you don't need to do that. We'll get into why you still need to do that in a little bit. But I mean, they scoff at it. They say, well, that's just a waste of energy. I have to put another asterisk in the middle of this and mention that when there's a lot of evidence that a treatment works, if we're doing a double-blind study, let's say, and we've got participants who are getting the placebo version of the treatment, and we got other participants who are getting the real treatment, and it becomes clear during the course of the study that the real treatment is actually working, they will actually shift gears, and the people in the control condition will start to get the treatment. They say, okay, we have enough evidence of efficacy that we can start to administer the treatment to the control group. They don't just go, well, too bad, so sad for you, you were in the control group. They start to administer the treatment. So the fact that pseudoscientists will act like part of the reason why they don't want to do controlled research is because they would be depriving people of the awesomeness of their treatment is a little disingenuous. It actually shows you that they really don't understand how science is conducted. Because if they knew how science was conducted, they would realize, well, obviously the control group would ultimately get the treatment anyway. All right, so all of that was a big setup just so that when I show you this video, you'll understand what they're talking about. And this is a Discover News little piece that's trying to be, sort of engaging for us, explaining how to spot pseudoscience in the evidence that might be presented to you. So enjoy this video, which will run next in your playlist.